Here comes the AI tag detection and decoding algorithm. We are using MATLAB to write this algorithm. Overview of the process. From the webcam, we are feeding the input image to the algorithm, and from these images, we are determining the rectangular coordinates of the AI tag. Using that coordinates, we are feeding these coordinates to the homography, which is responsible to orient the AI tag in a proper direction. And the output of an homography is an AI tag, which is in the grayscale format. Using that AI tag, we have written our own custom-made AI tag decoding algorithm, which is responsible to decode the AI tag, and it displays ID as well as the AI tag, and the whole process will repeat continuously in real time. Coming to detection of rectangle boundaries of an AI tag, the image which you are feeding is an RBG format, and we have to convert into binary image. And that converting into binary image, we just have to apply a grayscale, and after we are applying into the binary format via a Gaussian filter, which is responsible to filter out these images. And this binary image is fed into a SOPY edge detection method, which is responsible to determine the edges of the boundary. And we are eliminating the noise in the edges by using erosion as well as dilation function. With this edge detection image, we are filling this image using IAMFill function, and this filled image we are feeding it to the BW boundary function, which is determining the boundaries of each and every filled image. And using these boundaries, we are feeding into Douglas-Pelgel algorithm, which is responsible for giving the coordinates of the AI tag. And this is how we are determining the coordinates. And here comes the code of the AI tag detection algorithm. This is in the RBG input which are giving, and this is the Gaussian blur function, and here is the edge detection SOBY, and here we are filling the image, and here beware function given the boundaries, and here is the Douglas-Pelgel algorithm, it determines the edges of the corresponding function, and here is the final coordinates which is stored in the final corners, and these corners we are feeding into the homography algorithm, and this is the reference frame which we are setting 600 cross 600 pixel, and this is the final points of our AI tag, and we are giving these reference points as well the final points to this function, and it will give output as a transformation matrix, and this transformation matrix is corresponding to the transformation of that AI tag in the image to the reference frame, and we are applying this transformation, and we are extracting that AI tag from that image, and we applying gray scale image to binary image, and here this the binary image we are feeding to the decode AI tag custom made algorithm which is giving to that, and it will output the image as well as the decoding ID. And now this is the algorithm which we have made for decoding the AI tag. It requires the input, takes the input as a binary format, and n corresponds to the number of rows in squares in the corresponding AI tag. And now this image which you are splitting into n cross n individual spots, individual individual columns, we are going to each and individual square at the centroid and measuring the data of that corresponding AI tag. Here I and j represents the row and column of that corresponding image, and d is the data which you are storing the AI tag data. And now here is the image img is the corresponding image which you are reading, and we are reading at the corresponding center of the each and every block and storing the data in the d. And this is the function which when we determine that AI tag as a 1, now we then AI tag as a 1, we will mark it as black, and if we determine the AI tag as a white, 0 we will mark it as a black, and this is how the function will work. Now test the algorithm. I am feeding the algorithm with this function. You can clearly see that this is the input which are given, and it determines the input, and this is the binary image, and this is the edge detection image, and this is the image which is filled, and this is the final decoded AI tag. And now let's play with another image. We are running with another image, and here comes the image. We have to apply the adjustment. Now you can clearly see that this is the input image which are feeding to the algorithm, and it clearly detects the AI tags, and here is the binary image of the corresponding input image, and we are applying the edge detection, and we are filling this image and feeding it to the homography algorithm, which is responsible to determine the corresponding decoding this AI tags individually. Thank you.